Hi, in this video we'll talk about the storage organization, style allocation of the space and the runtime environment. To start with, we'll start with the runtime environment. Now, what does this topic deal with? It deals with the space allocated for the target code which is generated and also for the data object for the source program when it has to be executed. Now there are certain data objects which we know well during the compile time itself, and there are certain data objects which we have to know, which we come to know only during the runtime. So if I know the requirement during the compile time, we always do it in a static manner, static allocation. Whereas if it is not known during the compile time, then it has to be taken care by the runtime support package. Now the allocation and the deallocation of all the objects, it is taken care by the runtime support package. But then how do we really understand all this, and how do I demarcate between the data object which I know during the compile time and the data object which I know only during the runtime? If there is a recursive call in the program, how do we address it? Is all what we have to discuss about. Now, while I do an execution of a program, or where you call it as when it is in process, then we have to talk about certain informations. When there is a main program, there can be many function calls inside it. So you try to identify which are all the procedures or the functions which are active. So this execution of various procedures and the way of tracking of all the procedures, you call it as an activation of that procedure. When a procedure is under execution, you call it as an activation of the procedure. Now you also have another terminology called as lifetime of a procedure. What is lifetime of a procedure? From when you execute a procedure, the time from the first instruction is being executed till the last instruction inside the procedure, you call it as the lifetime of the procedure. That is the sequence of steps between the first and the last steps in the execution of the procedure. So now, if A and B procedures are not overlapping or not nested together, then A completes and then you start with B. But then if B is inside A, B is inside A, then A's procedure will be active, and upon which B's information will be pushed in. Once B terminates, you can go ahead with A. Now if it is a recursive call, maybe factorial of n. For n, you have an activation of the procedure n minus 1, n minus 2, n minus 3, and it piles up. So that is how your procedure, activation of a procedure is stored in. So now, in order to identify how the procedures are being executed, we have it in terms of a tree structure, which we call it as an activation tree. And every node represents the activation of a procedure. You will have a root, which is the main program, and if A is a parent of B, from A we will have a edge to B. B will act as the child node. If A completes and then B starts executing, A will be to the left of B. Now with that information, we'll just see an activation tree. Now here you have the main method, and inside main method you have two procedure calls. One is P and the other one is S. And if you try seeing P's information, P has two procedure calls. One is Q and the other one is S. Now what happens when you have an activation for record for the main method? Once that is done, when the P's information comes in, you say P's activation record will be stored. What about the mains activation record? It's like a stack. So mains activation record is below, upon which P's activation record has been placed. And then when still P is active, you have two function calls inside P. So what happens? Upon P, Q's activation record is there. But then Q and S are sequential. So what happens? Q executes, finishes its execution, and then Q's activation record is popped out, and then comes the activation record of S. S activation record also pops out, and then P completes its execution, so it goes off, and then you have the main method upon which the activation record of S itself. This is how the activation is. So you have the main as the root, and then these two are sequential. The first one is P and the next one is S. So to the left of S you have P, and inside P, will P is still active, you have Q and S again. So this is how an activation tree is all about. Now this is other way of representing. You have enter main, you entered P, you enter Q again, you exit Q, and then you enter S, exit S. After this you exit P, and then what happens, you enter S and exit it, only then you exit the main, which is a nested structure. Now how do I take care of all these informations? You have something called as a control stack. Now what is control stack? Control stack helps you to keep in all the information about activation of the tree, activation tree, or in other terms, control stack helps you to keep track of all the live procedures starting from the main method to all the procedures which are active at a particular point of time. If the procedure completes its execution, then we pop out the active procedure record out of the control stack. We also have to know a little bit about the variable scopes. One is, there are certain variables which are local to the procedure. There are certain variables which are global to the procedure. So now what happens, all the global variables will be stored separately. The local variables will be stored separately. So as soon as its completion of the procedure is over, that local variables information will be just popped out from the memory. It will be not stored any further. So all these things are explained here. You have something called as binding of names. When you say A is equal to 5, what really happens behind the screen is what we call it as binding of names. Now you have the name which is mapped with a storage, which we call it as the environment. When you say int A's value is mapped with some address, that is the storage, which you call it as the environment. And this storage can contain any value, which we call it as the state. So you have two processes. One is the environment and the other one is the state, where a name is being bounded with a value. There are certain static notions and its dynamic counterpart. When we define a procedure, inside we have an activation record which has been defined. When you declare a name, we have the binding of the name. When you talk about the scope of declaration, whether it's local or global, we talk about the lifetime of this binding which holds true. And this is what we all talked about. Now there are certain things which we have to really consider. Earlier, there are cases where you have to store the code, which is common. Every instruction which has to be executed has to be transferred onto the main memory. So you have a part for code. Now there are three things. One is, earlier they went only for static definition. So you will have only static data, and therefore they said this is the amount of memory where you can store the code, and this is the amount of memory where you can store the data, and it just went off. But then if there is a recursive procedure, when there came the object-oriented concept, when there came the concept of procedure and functions, this static allocation was not sufficient, because my memory can grow, the need for memory can grow, and therefore came with some information called as stack. But stack has one problem, whether it is last in first out. I cannot place here and there, it has to be one above the other. So for recursive functions, yes, it works good. Activation record works through and stack manner, this works fine. But later on we went in for dynamic allocations, where he played a major role. So what they thought is to define this as a set of memory locations for a given program to be executed. So the first set of addresses, we give it for the code, that is fixed, and then there is some fixed memory location for the static data, and then you have a set of locations where the stack grows downwards and the heap grows upwards. Stack helps to store all the activation record, recursive procedures and so on, all the run dynamic allocations is taken care by heap. So this is the overall runtime storage organization. Static cannot hold recursive calls dynamic allocation, and therefore they went in for stack, where the recursive and activation records whatever can be adopted with the help of stack was good enough, but dynamic allocation didn't work out. Therefore we have also incorporated heap. So nowadays we have code, we have position for static data, we have stack, as well as we have heap in a storage organization. Now we were talking about activation of a procedure, again and again. Now what is this activation of a procedure? It gives us some information of all the procedure which is in execution. Now what information does it give? It gives something called as an activation record. Now what does this activation record have? This activation record has the return value. It has something around 7 parameters. What is the return value? The value which has to be returned to the procedure which it has called is the return value, and the call procedure sends some actual parameters which is stored here. Now you have an optional control link. Maybe the main method calls the P method. P method will have a control link to the main method. So that is optional control link. And then if I have any non-local data which has to be referred, we can use the optional access link. Somewhere down the lane I have to save all the information, maybe the status register, the index register information and so on. That we call it as the saved machine status. The local variables, the local variable data objects will be stored here, and you have to have space for the compiler generated temporary variables, which we have it as the last part. So these informations put together, you call it as the activation record. Now when does an activation record gets generated? When a caller procedure, for if I have a main method and inside it if I have a method P, when main method calls P, you have an activation record which is pushed on to the stack, control stack. And once it stops its execution, or once it completes its execution, it deallocates the activation record from that control stack, and the control moves on to the caller which has called this activation record. This is the overall runtime environment and the storage space organization. Thank you.